Remember yesterday how we explained that we could wrap around a bunch of times, as we did in this example, and have angles ending in the same spot. So really we said that there's an infinite number of coterminal angles that can happen when we are talking about standard position angles. Today what we're going to look at, and where we left off yesterday, is basically how can we write all of those coterminal angles if we keep spinning around an infinite amount of times, either positively or negatively. What's a statement that we can write that would show all of the coterminal angles? So yesterday we started with this blue part up top. There are an infinite number of coterminal angles for any given angle in standard position. And then there's two sort of expressions that we have to know. They're not given on a formula sheet, but you're expected to understand them, how we can talk about the general form of any coterminal angle. And these are what they are. So the general form of any coterminal angle is just taking the angle theta and either adding or subtracting 360 degrees. So if we take the angle, remember if we took an angle, say, here, and I said this is 10 degrees, well, that's 10 degrees. I could also wrap around 360 degrees and then go to it. Now I'm at 370 degrees. So I can just keep wrapping around and around and around as many 360s I want. Or conversely, I can actually start at that 10 degrees and go backwards and backwards and backwards. That's why there's the plus or the minus. So we can go in jumps of 360 degrees, or yesterday we said multiples of 360, n times. So if I wanted to go around once, n is 1. If I wanted to go around twice, n is 2. 10 times, n is 10. So we can just keep wrapping around and around and around. So this is the standard form for coterminal angles in degrees form. Or we could say you take that theta and we add or subtract a certain amount of jumps, but now measured in radians. 360 degrees, remember we said, is just 2 pi radians. An amount of times. So again, it's the same thing as the one above it, the 360 degrees n. 2 pi over n, this 2 pi and the 360, those are the exact same numbers. If we're talking in radians, we spin around in 2 pi's to get complete revolutions, and in degrees we talk about it is 360 degrees. Some of the technical stuff that you're going to see on here, both of these n's have to be elements of the natural numbers. All that really means, if you were to see this on any other worksheet or something like that, all that is actually telling you is that n has to be a whole number, okay? Or sorry, a natural number. So we can do 1 jump, 2 jumps, 3 jumps, 4 jumps. We can't do negative jumps in 360 degrees, and we can't go 1.5 rotations, because as soon as we go half of a rotation, we're no longer at the same terminal arm. So these two things are important for us. The other thing we need to know is that angle theta has to be the principal angle. And the principal angle, that's kind of a new term for us, but it just basically means it's the smallest positive standard angle. So if you can get back to your smallest positive standard angle, then we're talking about the principal angle. So these two things here are what we're going to be doing right now, today, and using those. So let's jump into some examples right here. Determine the general form of the coterminal angles for 290 degrees and 150 degrees. So if we examine both of these angles, 290, that's the smallest. This is a principal angle. Principal angles have to be between 0 and 360. It's just one rotation. So 290 degrees, that's my principal angle. If I wanted to get a coterminal angle, all I have to do is either add or subtract 360 degrees any number of times I want. So there's the general form of the coterminal angles. You either just add or you subtract 360 degrees however times you want. That one's done. That's how I would get all of the coterminal angles. This other one now says, let's do the coterminal angles of 150 degrees, but I want my answer expressed in radians. So the first thing we want to do is change this 150 degrees into radians. Yesterday we said to change into radians is just 150 degrees times pi over 180. So if you do all the work and simplify it down, you should get 5 pi over 6. So you should be checking that you can actually do that in your calculator and actually come up with that. So 150 degrees is actually 5 pi over 6 radians. Now, if 5 pi over 6 radians is what we're looking at, we're saying that's my principal angle, 5 pi over 6, and I want to either add or subtract complete revolutions, a whole circle around to get to that terminal arm again, but in radians, that's just 2 pi times n. So this is the general form, or how we find the general form in radians. We just have to make sure that we have our principal angle. So let's take a look at a different type of question then. And it's going to say, you know what, let's try the same thing here. We'll try at example C, and I'm going to say, let's do the same thing, except I'm talking about 2080 degrees. I want to know in degree form and in radian form the expression that would show all the coterminal angles. Now, definitely you should be able to understand that 2080 degrees is not the principal angle. It's not the smallest one we have. One of the easiest things to do to figure this out, our principal angle, is take 2080 and let's divide it by complete rotations. So we're going to divide it by 360. If you do that, you're going to recognize that this is approximately 5, which means we have 5 complete rotations that we can do to get 2080. So if that's 5 complete rotations, what I should be able to do is say, if I started with 2080 degrees and subtracted 5 complete rotations of 360 degrees, what's left over? Because that would be my standard angle. If I do that, or my principal angle as well, I'm left with 280 degrees. So basically, if I uncoiled this whole thing, I would have started here and said, okay, I'm 5 degrees. So there's 1 rotation, 2 rotations, 3 rotations, 4 rotations, 5 complete rotations, and now I have to go an additional 280 degrees to see where this terminal arm is. Well, that would be way over here. So this is the angle we're actually looking at. And of course, this is a very exaggerated example just to see how we can do these questions. So if that's my principal angle for degrees, I'd say, well, if I started at 280 degrees and just added and subtracted complete jumps of 360 degrees, any amount of time I want, there's the general form for all the coterminal angles in degree form. And to get it into radian form, first thing you need to do is to convert this 280 degrees into radians. I'll just save some time. That ends up being 14 pi over 9. So if I wanted that as a general coterminal angles, it's going to be, let's start with 14 pi over 9. And let's add or subtract complete revolutions, which are 2 pi in radians, any amount of jumps I want. Now remember, I know most of you can understand this one. It makes sense to you. This one you look at and say, holy smokes, what the heck's even going on? Just remember, these are the exact same measurement. This is the exact same measurement. These are the exact same formulas, just expressed in different units.